Hello everyone, and once again I welcome all of you to the course on kinematics and theory of machine. So in the previous lecture we have already discussed about the inversion of mechanism. So we now know what is the inversion of mechanism. Then we have started discussing about the inversion of some common mechanisms. So we have in the last class discussed about the inversion of 4-bar chain. So in that we have said that there are 4 inversions. So first inversion, the application was in coupled wheel of locomotives. So second inversion, the application in the beam engine we have discussed, where the rotary motion was converted to the reciprocating motion. Similarly, third inversion, it is the application is one of the very well-known mechanism, that is the pantograph mechanism, which is particular is a device which is used to reproduce any kind of figure, drawing, maps, etc. in any either reduced or in enlarged scale. Similarly, in the fourth inversion, we have seen that the port inversion, what mechanism is the example, one of the perfect example. This what mechanism, it falls under a approximate straight line motion mechanism, where this particular point marked by red point, okay, in the GIF. So this denotes it depicts a particular straight line motion. So today in this particular lecture we are going to discuss about the inversions of slider crank chain. So here also 4 different inversions are possible. So just will be naming them as normal your first inversion, second inversion, third and fourth, and like that only. Okay, and we'll see what are the different useful applications of all those inversion. So if you already recall the slider crank mechanism, so with respect to this particular figure A we are discussing, so this particular position is the fixed. Here also it is, this guide is nothing but the fixed one. Okay, linked to it acts like a crank. Okay, this is nothing but the connecting rod, and number 4 link is the slider, which can slide along this particular, it can have this to and fro motion along this particular direction. This particular direction is known as the line of stroke direction. Okay, the stroke is, that means along this particular line. And now there are different configuration of the slider crank mechanism also is possible, as already we have discussed. So we may have offset type of slider crank mechanism, where the position of this particular slider, okay, or you can say the this particular position, okay, and this crank position, okay, this center line, okay, it may not coincide, there may be some offset in between them. Okay, so this type of slider crank mechanism will be known as the offset type. So now coming to this particular first inversion, so now this first inversion is obtained when link 1 is fixed and link 2 and link 4 are made the crank and the slider respectively. Okay, which is the normal case of our slider crank mechanism. So there will be like two application, one is a reciprocating engine and there is another one reciprocating compressor. So now when this particular mechanism becomes acts like a reciprocating engine, and when it acts like a reciprocating compressor. So now from this particular figure, if you see, then as shown in this particular figure, if it is a reciprocating engine we are talking about, okay, so then this particular piston, which is nothing but the kind of slider in our case, okay, or if we talk about with respect to engine, reciprocating engine, etc., then it is nothing but that is the slider is the piston. Okay, so when the slider is the driver, then it acts like a reciprocating engine, and whenever and if it is a compressor, that slider, if it is acts like a compressor in this particular case, and compressor, then 2 is the crank is the driver. Okay, so now whenever it is like this particular, this is the compressor, reciprocating compressor, then number 2 link is the driver. Okay, so this is the case. So whenever it is acting like, so this is nothing but this particular cylinder, so this is the piston, this blue part is the connecting rod. Okay, and here here it shows the crank position. Okay, so this particular white point, it is nothing but this is the crank pin position. Okay, so as we have already discussed in practice, this is just a configuration diagram of slider crank mechanism. Okay, but in practice, in application, it may look like this. Okay, so whatever guide we are talking about, so this cylinder is acting like the guide because the piston is moving in this particular direction. It is confined or it is constrained by this particular guide to move in this direction only. Okay, so this is the case. So if it is compressor, then in this particular position it is going to compress it. Okay, so next, second inversion is about, we are going to discuss about the second inversion. So our in normal case we already have this particular, we can draw like this also, no problem. So we can show like this. Okay, here also we can show fixing, no problem. Okay, so when fixing of the link 2 of a slider crank mechanism, then it results in this particular second inversion. So whenever we fix this link, okay, so it results in the slider crank mechanism. So now this particular figure, if you feel think that I have just rotated like this in this particular direction, so I can draw like this. Okay, and consider as if in place of number 1 link I have now fixed this particular number 2 link. Okay, so this becomes this particular configuration. So now the slider crank mechanism of figure, this particular slider crank mechanism can also be drawn as this. Okay, so now further, when this link 2 is fixed instead of this previous link 1, okay, then the link 3, which is this particular link, okay, link 3 along the slider at its end. So at the end of this link 3, we have the slider at the end of this link 3, correct? So the link 3 along the slider at its end B, it becomes a crank. So now this particular, as we have already fixed this, so this link behaves like a crank. That means it can have this particular rotational motion. At this end we have this particular slider. Okay, now because of this, what basically is happening, this makes the link 1 to rotate about this link 1 which was previously fixed. Now it is not fixed, that means it can have the movement now. Okay, and as this is a pin joint or hinge joint, so about point O, okay, and this makes the link 1 to rotate about this particular point O. Okay, and on this particular link the slider can have this reciprocating motion. Now this particular mechanism inversion can be used in the without quick return mechanism, and this particular inversion is also used in the rotary engine. Okay, so now this particular figure shows the without quick return motion mechanism. We already know from your manufacturing technology knowledge, this quick return motion mechanism, those are used in the shaper machines in the workshop. Okay, and along the during this particular stroke, okay, and quick return means the return stroke is achieved at a faster rate, okay, at a less time. And forward stroke, which is the cutting stroke, it cuts the metal. And which is the idle stroke, that is the return stroke, which is the idle stroke, when there is no material cutting and all, it accomplished in a faster manner. So if we discuss about this quick return motion mechanism, already we know it's a mechanism which is used in workshops to cut metal, basically in the shaper machine. Okay, and the forward stroke is longer, during that time it cuts the metal, and the return stroke is fast and actually it doesn't cut any metal, so it's an idle stroke. And if we discuss in terms of the angles, okay, so that directly the cutting time as well as the return time or the idle time, they are directly dependent on the angle swept during that time. Okay, so cutting there is a relationship, cutting time of cutting by time of return, it's equal to cutting stroke angle alpha divided by the return stroke angle beta. Now in a whole at this particular center, okay, we already know 360 degrees the angle swept in a complete revolution. Okay, uh, then if the cutting stroke angle is alpha and return stroke alpha, is beta, then we can write beta equal to 360 degree minus alpha. Okay, if this is one angle, this is another angle. Okay, so like that. So next is the rotary engine. So now what is this specific rotary engine? So this rotary engines in the older planes, airplanes, etc., this kind of rotary engines were used. Okay, so now basically what happens here, on a single common crank, okay, so multiple cylinders are there attached to it. Okay, and this whole system is rotating, the but the crank is the common crank. Okay, and now during this particular movement, so positioning of this, all those you can say positioning of this particular pistons, okay, inside the cylinder, it is different, and during this particular movement of this particular crank, okay, there will be that particular different like power stroke will be there, okay. Whenever it gets compressed, air fuel mixture gets compressed during that position. After that, burning of the fuel will occur, power stroke will get, expansion, etc., everything will occur, okay. We already know about all those four strokes, okay. So here in this particular GF figure, we can see that suppose whenever it is being compressed, so it will be compressed at a particular point, okay, and after that it ignites and all, okay, and the whole process continues throughout that particular different cylinder, okay. So next is the third inversion. So now in case of third inversion, by fixing the link tree of the slider crank mechanism, third inversion is obtained, okay. Now what basically happens, now the link 2 is again acts like a crank, which was previously crank only. Now if we fix this particular link, once again it is going to act like the crank. In the previous case it was not acting like the crank, we have fixed this. Because of that, this link acted like the crank in the previous case only. So what are the applications? Basically in oscillating cylinder engine and crank and slotted lever quick return motion mechanism, once again we can use this. So how basically this oscillating cylinder engine is working? So if you consider with respect to this particular figure, okay, the link 4, which is this, okay, link 4 is made in the form of a cylinder. That means some modification has been done on this particular link 4, and link 4 is now modified to look like a kind of cylinder, okay, and the piston is fixed to the end of this particular link 1. So link 1, it is being modified like this, okay. That means at this end of this link 1, okay, we have fixed the piston. So as we have already discussed, so this links, okay, modification of links, it is possible, okay. The look may be different, but the behavior we want to see basically, okay. There may be depending on your requirement in any kind of case of in any mechanisms, okay. So there may be certain modification is always allowed, and by doing modification only we have accomplished different tasks, okay. So now in this particular case, once again another thing that I want to discuss is don't just think like, okay, suppose first inversion is like fixing the first link, second inversion means fixing second link, third inversion means fixing third link. Don't think like that, okay. But the thing is everything comes with respect to this particular reference figure. As we have numbered this as 1, this link as 2, third and fourth, this sequence we have followed. That's why first, second, third, fourth, this inversion are following. Suppose if it is third inversion, we are fixing link 3 and all, okay. So it becomes easy in that way, but this is not the way to do it, okay. That means you should not think like, okay, first link fix, first inversion, second link fix, second inversion, like that. You should not think like that, but you should know basically which one is first link, which one is behaving like second link and all, okay. And if I fix this, what is going to happen, how it is going to behave, etc., etc., okay. So now in that particular case, what will happen if we do this modification like this, the piston reciprocates inside the cylinder, which is pivoted to the fixed link C. Now here is the pivoting, okay. Pivot means about this particular point it can have that particular oscillation kind of movement. So now because of this particular type of arrangement, as you can see from this particular figure, okay, GIF, okay, animation. So this is the pivoting point, okay. So this is the modification in terms of the cylinder, okay, and at the end of this particular link B, you see this particular slider is provided, okay. So which can slide along inside that particular cylinder, and as we have this particular pivoting at this particular point, it can also oscillate, yes. So because they are oscillating like this, okay, this arrangement is known as oscillating cylinder engine, in which as the piston reciprocates in the oscillating cylinder, the crank rotates, okay. So this way this thrust, that means that is also being provided. Next, once again we are coming to the crank and slotted lever quick return motion mechanism. So here also it's a kind of quick return motion mechanism only, okay. As you can very easily see, it is used in the uh, shaper machines in the workshop, okay. So this particular figure shows this particular animation shows it. Okay, this is the kind of crank. Okay, this is the slotted lever, that one, this bar kind of thing. You can see a slot there, and there is a pin there, okay, which is moving, which is acting like a kind of, we can say that end of this particular crank, okay, which is inside that particular slot. Okay, so it also slides along that particular slotted lever. Okay, and the motivation is at the end. Okay, we have this particular cutting tool. Let us switch it. So there will be like that, it is also a kind of quick return motion mechanism only. Okay, so you can see this from this particular diagram. So here what happens, this AB link that is fixed, okay, AO, it is acting like the crank, okay, and at its end basically the slider 1 that is there, okay, and CB, it is the slotted lever, and whenever this particular crank AO, it rotates, and during that time basically the you can say that in within that particular slotted lever, that particular point, that A, that is kind of behaving like the slider, okay, that also have this particular motion. Okay, and at the end the modification is like 5 and 6, it is different with that means 6 is the cutting tool, that cutting tool is connected with that particular link 5. Okay, and in the second figure it is showing our the cutting stroke angle, and the two extreme positions we have shown basically in the second figure. The two extreme positions are being shown of the oscillating guide 4. Okay, the time of the forward stroke is proportional to this particular angle we have denoted with theta. Okay, and whereas the return stroke, it happens during this angle, which stroke angle is beta. Okay, and right now we have considered as if the crank is rotating clockwise, okay, then it is happening, and during that time all of you can very easily see from this particular figure. So beta, which is nothing but the return stroke angle, theta is the cutting stroke angle, so theta is way much greater than beta. That means with the same angular velocity, to sweep angle theta we are going to take more time compared to beta, and with the same angular velocity to sweep angle beta, the for sweeping angle beta, the timing is less. Okay, so this angle, okay, the angle of cut and angle of return, with it basically the both the timings are associated. Similarly, fourth inversion, the fourth inversion is the slider mechanism we obtain by fixing the link 4. Okay, the link 3, it can oscillate whenever we are fixing link 4, we are going to get this particular 14%. Okay, now link 3, it can oscillate about a fixed pivot P. This is link 3 on link 4. Okay, this makes the end of the link 2 to oscillate about B, and the end of end O to reciprocate along the axis of fixed link 4. So where is the application? Application is in hand pump. I believe most of you have seen hand pumps here, and maybe from this figure it is evident. Okay, so in hand pumps basically this particular inversion is being used. Okay, and here this link 4 is made in the form of a cylinder. In the actual practice, that means in the actual application is hand pump, and I have already discussed that any modification is possible. Okay, these are theoretical configuration diagram, but to do some to apply it, we have to have some whatever is the required modification to be done. Okay, and in the case of hand pump, which is an example of fourth inversion of slider crank mechanism. Okay, so here in the link 4, that is made in the form of a cylinder, and a plunger is fixed to the link 1, which reciprocates in it. Okay, this plunger is fixed in this particular link 1, okay, which can reciprocate. Okay, and after that all of you already know, whenever we this is the kind of the handle, okay, and this link 1 can move up and down, plunger is done, then suction pressure will be generated, and we are going to that all of you already know hand pump, that is the tube well we said. Okay, so that is it. Okay, and that's the 14th version of it. So in the next lectures we'll be discussing basically about the inversion of double slider crankshaft and what are the different mechanisms that we obtained. So thank you.